Okay, let's see. What do we got here? We have arc length and sector area. Okay, so these are some geometrical things. So I don't know what your geometry teacher taught you, but I'm going to tell you this. Okay, since I'm your teacher now, let's do it like this. Arc length. So arc length we're going to call, I don't know, AL. That's where we go. AL, arc length. And an arc length always has an arc over the top of it, right? To differentiate it between a segment or a line or a ray, right? Those are all geometric things. So AL we're going to call arc length. So the arc length is a portion of the circumference of your circle. Okay? Arc length is a portion of the circumference. Right? Circumference is all the way around the circle. Well, the arc length, so if this is your circumference, there we go. Bam, bam. The arc length would just be part of it. So any part along the outside is considered an arc length. Okay, the circumference is also an arc length. It's the entire length around your circle. Okay, circumference has a formula though. So let's go ahead and erase that. Circumference is also known as 2 pi r. Or I guess we can consider this pi times the diameter, right? But usually we're given the radius of our circle, so 2 pi r is the formula that makes the most sense. So arc length is a portion of your circumference, okay? And it's in proportion to, well, for every arc length, there is an angle formed called the intercepted arc. Okay, the intercepted arc. Maybe this is 64 degrees or whatever else, okay? So it's in proportion to whatever that intercepted arc is. So the measure of the arc, right? The little m stands for measure. So measure is a degree. So this is a degree over, well, the entire circle's degree. Hopefully you know the entire circle's degree is 360. Okay, so notice over here on these side, these are lengths, right? Meters, inches, centimeters, miles, hectometers, whatever, right? These are lengths. On this side of our proportion is degrees, okay, about the angle. The angles are in proportion and the lengths are in proportion. So we'll solve this simply by cross multiplying. Okay, when we have a fraction equals a fraction, we solve by cross multiplying. So that's if we're talking about arc length. But what if we're talking about sector area? Okay, so a sector area you can think of as a slice of some round object, right? Pizza is usually round unless you get a square pizza. Well, the slice of that pizza, one slice, as long as it's cut with a diameter in mind, that one part is called the sector. Okay, so one sector is a proportion of the entire area, right? So a sector is a proportion of the entire area. Your circle area formula is pi r squared. Pi r, so knowing the radius is a pretty important part in order to find this. So the sector area divided by the entire area is in proportion to that same thing as before, the measure of your arc. Okay, it's all about the angle. What is the angle that's formed here? That's called a central angle. A central angle is equal to the intercepted arc. Okay, so this is a degree, the measure of your arc length, I guess the measure of your intercepted arc. Just using the same terminology as before, over 360. Okay, so sector over pi r squared equals the arc measure over 360. But because this is pre-cal, we're going to do a little bit of manipulation. Okay, and turn this into some pre-calculus. So 360 degrees is what as a radian angle measure? 2 pi. Okay, so we're going to change this. So arc length over 2 pi r equals theta, right? Theta is our radian angle measure. So this is a radian angle, like pi over 6 or 5 pi over 4 over 2 pi. Okay, so what happens if we solve this? We're going to cross multiply. Let's cross multiply real quick, because we're going to come up with a real simple formula. 2 pi times the arc length equals 2 pi radius times your radian angle. 2 pi times the arc length equals 2 pi r times the radian angle measure. And what happens if I divide both sides by 2 pi? I get a stinking simple formula that says the arc length of your arc, right, the length of your arc equals the radius times the angle, but as long as the angle is in radians, right? This angle has to be in radian angle measure in order for this formula to work, right? This super simple formula, r times radian angle. Similarly, over here, right, we have sector over pi r squared equals theta as a radian over 2 pi. So if I were to cross multiply and divide, I would find out the sector equals pi radius squared times theta over 2 pi. What can cancel out? The pi's can cancel out. So my sector is 1/2 radius squared times theta, as long as theta is a radian angle measure. Okay, so whatever you want to do, you can remember the ratio down here, or we can remember the simple formula, as long as you remember that the angle is in radians. So how do we change from a degree to a radian? Because most of our problems are given to us in degrees. Well, let's spend a minute talking about that, and then you can choose however you want to do it. So if we want to figure out what the radian is, theta, it's the degree times pi divided by 180, right? This is our comparison. Pi radians equals 180 degrees, right? Pi radians equals 180 degrees. So using some chemistry stoichiometry, right, the degree will cancel out with the degree, and we're going to have our angle in terms of a radian. Okay, and this can be a decimal, this can be a nice pretty one, it doesn't really matter since we're using our calculator anyway. But the angle in radians, a radian angle, is equal to the degree angle times pi divided by 180. Okay, so let's do a couple of problems and see which one you like best, right? Because that's the instruction. Now let's do the application. So we'll do it both ways. How about that? Here is your circle. So some geometry. What does the box mean in geometry? 90 degrees. And AD is a diameter because it goes through the center. So if this angle is 70 and this angle is 90, what's the measure of my missing angle down here? Because it's 180 minus 90 minus 70. This is a 20-degree angle. Okay, so once again, if this is a 70-degree angle, this is a 70-degree arc. This is a 90-degree arc. This is a 20-degree arc. And then this one is a 180-degree arc, right? Because that's a diameter. A diameter splits your circle in half. So a half of 360 is 180. Okay, so there's some geometry that we might have forgotten about circles and their angle sums. Okay, let's go back and see what we want. We want the length from A to B. From A to B. Okay, so arc length of AB. So AB over 2 pi r. R is 5 equals the angle of AB, which is 70 degrees, right? 70 degrees over 360. Okay, so that's using our ratio. The arc length over 2 pi r equals the arc measure, which is 70 degrees, over 360. Okay, so let's cross multiply and see what we get. What's 5 times 2? 10. 10 times 70 is 700 pi over 360. Right? 10 times 70 is 700. It says leave your answers in terms of pi. So how can we simplify 700 over 360? Well, I know that the zeros cancel, right? That's a 10 divided by 10. 70 and 360, they're both even numbers, so I can divide them both by 2. 70 divided by 2 is 35. 16 divided by 36 divided by 2 is 18. Can 35 and 18 be reduced to anything? Nope. So then this is your exact answer, 35 pi divided by 18, and my units are meters. Now, let's go to our calculator and see what that is. What is 35 times pi divided by 18? So whenever we are rounding, whenever we are approximating, we're going to do 3 decimal places, maybe even 4. Okay, 4 decimal places is probably even more accurate, right? If you're ever going to take an AP class and you're going to decimalize something, 4 decimals is the standard for accuracy when you are changing from a perfect fraction into a decimal approximation. Okay, so let's do a little thing and do this instead using our formula with radians. Okay, so 70 degrees is how many radians? 70 times pi divided by 180.
1.223.
Which is approximately 1.223. So then what if I were to do 5, the radius, times 1.223? What is 5 times 1.223? Hopefully, it's pretty close to 6.109.
6.115.
6.115 meters. Okay, so then why is it different? Right, well, first of all, this number right here, this is an approximation, right? That's where we're chopping off a whole bunch of digits of pi in order to get 1.223. So if that is a approximation, when you multiply it by 5, it's going to become an even worse approximation of our actual answer. Okay, so if you're ever going to take upper division math, right, we talk about error. If you approximate early and then you use that approximation with other calculations, you are introducing error into your problem, where your answer is going to be farther away from the true answer. So if we did this times 5, I'm sure we would get something closer to 6.109 if we didn't approximate with a 1.223. Okay, so either way, we're going to get an answer, and hopefully your teacher knows both ways. Let's do number 4, CAD. CAD. So in geometry, this means that we start at terminal C. Okay? We're going to start at C, and we're going to fly in the direction of point A. Right? So this is all about direction. What direction around of the circle are we going? We're starting at C, and we're going all the way around through A. So we take a flight from city C to city A, and then we continue all the way around the world until we get to point D. Okay, this is like flying from New York to Los Angeles by going over Europe and by going over Asia and over Russia and then coming all the way around the Pacific Ocean over the United States to get all the way to San Francisco or Los Angeles, right? The long way around. So that's important to understand what this means, CAD. Start at point C, go through point A on your way to D, right? Not very efficient, but mathematically correct. 2 pi 5. So what is that arc from C all the way around to D? 340, right? It's 360, the whole entire circle, minus 20. So 340 over 360. Okay, so we cross multiply, divide by 360, and let's just approximate that. Let's don't leave it in terms of pi. 29.6706 meters when we round to 4 decimals. Okay, so pretty easy there when we have an arc length. Now let's do an algebraic problem. Okay, the length of the arc is 16 pi centimeters. So now we know the thing here. We know this is 16 pi. If the intercepted arc is 80 degrees, what is the radius? Okay, so we know the arc length, so that goes in the numerator. Our formula is 2 pi r in the denominator equals 80 over 360. Okay, so we're going to do some cross multiplying. We solve by cross multiplying. 2 pi r times 80, 360 times 16. In fact, let's just do some simplifying. 16 divided by 2 is 8, so we have an 8 in the numerator. Pi over pi, well, that's just 1. So basically, it's 360 times 8. Okay, a much smaller, probably easier number to deal with. And then 80 times r, well, that's just 80r. So divide 2880 by 80, and we get exactly 36. So this circle has a radius of 36 centimeters. Okay, so now let's look at these sector problems. A sector, remember, a sector is a slice. So DEC. DEC is the sector that involves point D, point E, and point C, right? This is the sector for DEC. It goes from the circle outside to the center back to the outside. Okay, so area of the sector over pi radius squared. Pi r squared equals 20 over 360. Okay, or if we were going to use our radian formula, area of the sector equals 1/2 5 squared times 20 pi over 360. Okay, you take your angle, multiply it by pi, and divide it by 360. So on the right side, doing the algebra, we would have to do 25 times 20, right? Because 5 squared is 25. What is 25 times 20? That's 500 pi over 360. So 500 times pi divided by 360. If we round that to 4 decimal places, then the sector area is 4.3633, and our units are square meters. Okay, area always has a squared unit. So 4.3633 square meters. Let's come over here and see what I get. Well, this is your, let's see here. Let's see if we can simplify. This is our 25, right? 25. This is our 25 times 20. there's your 500 divided by 360. But where does the 1/2 come in? That's where this was a 180, so not over 360, over 180. And I get the exact same answer, 4.3633, that I did using the other method. Okay, so if you want to convert it to radians, right, that kind of simplify. I don't know if it simplifies it or not. Whatever. So number 10 is once again an algebra problem. The area of our arc is 20 pi centimeters. If the arc is 200, what is the radius? So we know the sector of the area, so that's 20 pi, right? The 20 of the pi's can cancel out. We'll do our cross multiplication. 20 times 360, that's 7,200, equals 200r squared. So we'll divide both sides by 200. That's 36. And our last step is to take the square roots. So this would have a radius of 6 inches. Okay, so just some algebra thrown in there. Can you solve this equation for r just like we did with the arc length? Okay, so if we have a radian angle measure, we have a radian angle formula. And if we have a degree angle measure, we have a degree angle formula. Have a fantastic time doing these problems.